Today we're bringing the curves into things. We're going to study mirrors that are like that and mirrors that are like that in general. We'll go into more detail later, but right now this sucker is a convex mirror, this sucker is a concave mirror. And spheres are nice because you can make a sphere, I mean you can make a circle anyway, by getting a fixed distance from a certain point and doing something like that. Right? So that's very repeatable and very circular, and this is where we started from. I'll call that the center point. And if I draw a horizontal line right here, I could call this the principal axis. Let's see, principal, not like the guy who runs the school, but like that, the main one, the principal axis. So I've got this center point right here, and the cool thing about a spherical mirror like this, now this guy is concave because I'm thinking the action is over here, and well, it's hard to tell the difference right now, but I'm gonna say this is a concave mirror, and so the shiny side is right there. Shiny, and the back side's all boring like that, black or something. And so here's what I need to do. I need to talk to you a little bit about how these rays work. And ultimately I'm gonna introduce you to 4 different rays that will help you understand how stuff works. But let me just talk my way through it a little bit. First of all, you saw that I had my finger here and the marker was right there. And so you know that if I have a ray of light that's coming this direction, it'll hit the mirror, and in fact it'll be exactly normal to the mirror when it hits, which means it will come right back along that same path. So this is one way that light could go. If it's coming right here, this is a cool simplification, if it's going this direction, then on its way back it will go exactly the same and go through the center of curvature again. Another cool thing about mirrors is that if you've got, well, let me talk about another kind of ray. What if I have a ray of light that's coming in here and it's gonna hit this part of the mirror right here? That guy right there is going to come in and it's essentially hitting a flat mirror. It doesn't actually know that the mirror is curving left down here and it's curving left right there. It knows that it's hitting a flat mirror, or it believes that it's hitting a flat mirror. So the cool thing about this kind of ray is that the incident angle is the same as the reflected angle. We're not going to name these guys yet, but these are some of my rays. Another kind of ray that we could have is, well, we could have see, this is a little bit complicated. What if I have a ray of light that's coming in parallel to the axis? Now that's interesting. If it comes in parallel to the axis, it's not actually going to come out and hit the center because it would have to be pointed like that to do it, but it's going to be, it's kind of, this is a little bit interesting. If I make a normal to this guy, the normal is always pointed at the center, right? And that's why if the incident, that's why we could argue here the incident is the reflected angle for this guy because it's just 0 equals 0. But I'm gonna say it's reflected about that normal right there with the same angle as it came in, and the cool thing is it goes through right there. And so if this angle is the same as that angle, are you with me still? That angle is the same and that angle is the same. It's going through this point right here. What if I give you a different ray that's coming in parallel to the axis? Let's say we'll do this one or something. Yeah, a little bit bigger. I'll do this one, and it's gonna hit here, and it's got to be reflected about, oh yeah, look at that. It's got to be the same angle as that, so it's got to be coming out here and do something like that. There must be something special about this point right here. Maybe you're not convinced. I'll do one more ray. This one will be a gray ray. Hey ray, gray ray. Here, this is a little bit, I'm gonna come in here. I'm gonna go like this. And notice the incident angle, as defined as the angle away from normal, is actually very small. The angle away from normal is like right there. And so I'm going to have an outgoing ray that goes like that. This point right here is super important, and I'm going to call it the focus. That's the focal point for this mirror. Now the problem is, of course, circles don't quite do that, because if I were to continue drawing this circle, oh good luck trying to fit onto one that's already existing, but we'll see what we can do. I'm going to say that if I continue drawing this circle, ultimately it's going to go horizontal, and so stuff coming in right here will not go through that point right there anymore. So that's the problem with circular things. They're easy to make, but you get what's called spherical aberration. And nobody likes aberrations, in particular not spherical aberrations. So what you want to do, how about spherical collaborations? That'd be fun. What you want to actually do is make a parabolic reflector. And a parabolic reflector, I mean, you know the principle of parabolas. There's a focus right here, and stuff's all like booch and booch and booch. Everything goes through the focus. And that's what you want to do when you're making a mirror. Now, there are two other things I need to say before we actually start drawing rays and understanding how to form images with mirrors. And that is, first of all, you have to assume that when you're using a mirror, you're near the axis. And this is because spherical aberration is magnified as you further away from the axis. And you want what's called paraxial rays, so that they're very close to the axis. But we don't want to draw paraxial rays because paraxial rays get really cluttered if they're all right on top of each other. We want to draw rays that are spread out from each other to understand it. So when I drew this ray hitting right here, I was actually making a technical mistake. What I want to do is draw this red ray coming in here and going all the way to the plane of the mirror. So this is weird. We're pretending like the mirror is actually perfectly flat, and we're saying, oh no, then it will bend like this, as if it hit a curved mirror up there. So I guess what I'm suggesting is instead of actually having a mirror that is bulky and bends into everything that's happening, instead of having that, I want a mirror, watch this. I want a mirror that's filled with little bits of mirror that are more and more angled to reflect the fact that the mirror should be getting more angle here. Let's see if I can draw this. This is called, after a great Frenchman, it's called a Fresnel mirror. And guess what? It takes a lot less glass to build this. I'm just chopping out this piece of the mirror here. See, I don't need all of this glass right here. All I need is the angle of the surface, and this maintains the angle of the surface but has a whole bunch less bulk, and it enables me to do the reflections at this plane right here. So this is a much nicer kind of mirror. Lenses can be made like that, and let's see if I can spell it right. Yeah, I think I did. So that's the kind of mirror that you want, a Fresnel mirror. And these suckers are really beautiful. You can make them out of glass and you can put them in lighthouses. They're very old school. 1800s kind of awesome. Maybe even older than that. I should look that up. Okay, so our next video is going to go into naming these rays and actually defining exactly what they do and how they're useful. Should we talk about... Nah, we'll leave it like that. Bye.